Hi everybody, this is video 3, identities and contradictions. So we're talking about inequalities and we're talking about special cases and weird things. And the first one of those weird things that we're kind of talking about, and we've done this before with equations, which is when we have variables on both sides. So variables on both sides, we talk about how we want to move the variables to one side, right? But this is where it becomes super important, because when we talk about variables on both sides, before we just wanted to move it over here. But here, remember, if we move variables to one side and they end up being negative, well then we're going to have to flip the sign, and that we don't want to do. So let's talk about this. So I look at this equation and I say, all right, there's some stuff I need to simplify here. I see that I have an n and a negative 3n. Those are like terms. I can add those like terms. N plus negative 3n is negative 2n. Plus 5 is less than 2n minus 3. Now, I have two n's on both sides, and this is where stuff gets tricky, right? If I subtract 2n from both sides, that would get rid of that n, but that would end up with a negative number. And remember, if I end up with a negative a negative coefficient, I'm going to have to, when I divide, I'm going to have to flip that sign. So I'm going to try to avoid having negative coefficients. So the way I can avoid that is, instead of subtracting 2 to get rid of this side, I'm going to add 2n to get rid of this side. And we talked about this when we did equations. We talked about how you want to look and you want to see which one's going to make it not negative. Well, this is why, because we don't want to end up with a negative coefficient. So I do that, negative 2n plus 2n, that's 0, but I don't need to write the 0 because I have this 5. And 2n plus 2n is 4n. I write that down and bring down the negative 3. And now I'm ready to solve this. This is a two-step equation that will let me solve. So I go through and I circle my variable. The thing that touching is the coefficients. There's my coefficient. And the constant is the number that's on the same side but doesn't touch it. So I have that. 2, 1, 0 solves it. So let's solve it. So I get rid of a minus 3. The way I get rid of a minus 3 is do the addition property of equalities. So what I do to one side, do the other. Now I just said addition property of equalities, but actually it's the exact same property, but we call it the addition property of inequalities. So we go addition, and we'll call it POI. It stands for addition property of inequalities. If it was addition POE, that would be the addition property of equations. Because it's an inequality, it's the addition property of inequalities. It's the exact same property. We just call it different names because an equation is the equal sign, and inequalities, it's an inequality sign. So, addition property of inequalities says I can add to both sides, and I get 3 plus 5 is 8, and I get negative 3 plus 3 is 0, but I don't need to write that 0 because I still have this 4n. And then finally, I got to get rid of that coefficient. The coefficient was the 4, so I'm going to divide by 4 and divide by 4. 4 divided by 4 is 1, that just leaves n, and 8 divided by 4 is 2. And do I need to flip a sign? The answer is no, because I didn't divide by a negative number, so I'm done. Now if I wanted to write that differently, I might want to flip it around so that the n's on the left side, but just remember that right now, there's an alligator facing the n. So if I decide to put the n the opposite side, which is fine, just remember that the alligator is going to follow it. So if it's a mouse, the mouse is going to follow it. If it's an alligator, so the greater sign was with the n, so when I flip it around, that alligator still has to be with the n. Both of these are correct answers, just be careful. So, we talk about that. If there's variables on both sides, try to keep it positive. That way you don't have to divide by, you don't have to flip the sign because you're dividing by a negative. It's a big, big help. But when we do these, sometimes we end up with something called an identity. We did this before with equations, and you're saying, what are you talking about? What I'm talking about is here I have an equation with variables on both sides. So I do my little lollipop, divide the equation into two sides, and I say, okay, I have variables on both sides, so I need to move the variables to one side. And so I say, well, which one's smaller? I go, oh, they're the same. So I go, okay, well, then it doesn't matter, so I'll just minus x from this side, and if I minus x from one side, I have to do it to the other. That's called the subtraction property of inequalities. The sub-POI, that's just the abbreviation of it. And so I go, okay, this ends up being 0, and I don't need to write it because I have a 1. and this ends up being 0, and I don't have to write it because I have a 7. And then I just look at my statement. The statement says 1 is less than 7. Is 1 less than 7? And you look at the number line, well, that's pretty obvious. And here's the 1, right? 2, 3, 4, 5, 6, 7. 1 is to the left of 7, and less is left, so 1 is less than 7. This is a true statement. So what we call this is an identity. It lets us know, an identity lets us know that any number that I put into or substitute in for the value of x will give me a true answer. Now, in the past, we've called that infinite solutions, right? We abbreviated it like this. Here's the problem is we can't use that term infinite solutions anymore. And here's why. It's going to kind of stick with me for a second. If I give you an inequality like this, x is greater than 2. That means I'm on a number line. And x is 1, and we'll call this 3. And so I would circle the x, which is the 2. And x has an alligator facing towards it, so that's greater, so we're going to the right. And so this is the inequality, the graph of the inequality. What this is saying is any answer bigger than 2 works. Well, guess what? Any answer bigger than 2, there are infinite answers. Hear the word there? Infinite. You say, what do you mean infinite answer? Well, I can go 2, 3, 4, I can do 3, 4, 5, 6, 7, 8, 9, 10, a million, a billion, a trillion, quadrillion, quintillion. I can do 2.01, I could go 2.001, I could do 2.0000. All those things are greater. So there are actually infinite answers that are greater than 2. So if we say infinite solutions, well, guess what? This has infinite solutions. They are infinite solutions that are greater than 2, but they're still infinite solutions. So we avoid this word here. So instead we're either going to write identity, or we can write this. Do you see where it says up here, all real numbers are solutions? Real numbers are a number group. You know how they were like whole numbers, natural numbers. In the 7th grade, you learned about integers, positive and negative, right? Integers. So integers were whole numbers and negative numbers, right? Whole negative numbers that represented, and they were a whole number group. Well, real numbers mean any number. Any number you can think of, that's a real number. Pi, that's a real number. 17 divided by -2, guess what? That's a real number, right? And so what we do is, instead of saying infinite solutions, because this has infinite solutions, if it's an identity and everything works, we're going to say all reals. And this is, the word reals stands for the real numbers, or you can write down if you want to be cool about it, and you're going to learn about this in our next unit called set node notation. This is the symbol for reals. It's basically a double line with an R. This is the symbol we use for real numbers. So we're saying all reals. So you would write this, or you can spell out all reals if you have an identity. But really quick here, because I know Mr. Nelson's talked about this with his students. Remember, you only can have an identity if you have variables on both sides, and when you go to solve, they go away. If you end up with no variables, if I end up with this, x is greater than 4, did x go away? No. So then I have an answer. But if I do anything and the variables go away completely, they just disappear, that means I have either an identity or the next thing we're going to learn, which is a contradiction. All right. Remember, you can rewind if you want to relook at anything on the video. So here's our next one. Again, hopefully you're writing this stuff down. This is called a contradiction. When solving an inequality, if you get a false statement, it has no solutions. And so we say, what do you mean? Well, this is what I mean. I have this inequality. I circle the inequality sign. And I say, okay, before I start, I got to move the variables to one side. And I look, and they're both the same again. So I go, okay, negative x can get rid of x, and negative x can make x turn to 0, right? And x minus x is 0, but I don't need to write it because I have a 7. I bring down the sign, and then I go, okay, but x minus x is also 0, but on this side, I don't have anything else, do I? So I have to bring down the 0, right? Where are my x's? They've gone away. But I look at my statement, and I say, is this statement true or false? Well, let's look at a number line. I go 0, 1, 2, 3, 4, 5, 6, 7. Here's 7. So is is 7 less than 0? Well, 7 is to the right of 0, so how can it be less? Less is left, and greater is right, or greater is right. And so because this is saying 7 is less than 0, that's not true. That's a lie. 7 is not less than 0, so this is false. And if it's false, then it's not an identity, it's something called a contradiction. It's saying it's a lie. And the reason why we call it a contradiction again is because in math, we assume the sign's always telling the truth. If we say it's equal, then we assume it's always equal. If we say it's an inequality, we say it's always an inequality. But when we get an answer that's false, then this is a liar. So it's a contradiction. It's contradicting itself. So you either write contradiction, but you can also on this one write no solution, or just put no soul, S-O-L, right? Because there are no solutions that work. It actually works for both. Just you can't do infinite solutions. All right, Mr. Nelson's going to jump up here and do a couple more of you for him, because I'm sure you're tired of hearing from me, so I'm just going to be in the background giving him a hard time.
So if you haven't already, go ahead and pause the video and try this one out and see what you get. All right, hopefully you paused the video and did that. I'm looking at this problem here, this inequality, and it is an inequality because I see an inequality sign. I'm going to go ahead and look at both sides and make sure they're simplified first. I'm going to go through GEMDOS on each side, and then I'm going to start getting, looks like I've got variables on both sides. I want to get that variable to one side as well, just trying to see what I have to do to this problem before I attack it. So I'm not going to do a lollipop because I need to simplify, right? We got to go through GEMDOS. Let's look over here on the left-hand side. We got 8 plus 5t minus 2. I'm looking for grouping symbols, exponents, multiplication, division. I can't do the multiplication here. And then addition and subtraction. I've got 8 and a negative 2. Those are like terms. And in addition and subtraction, in GEMDOS, we combine like terms as well. So let's go ahead and combine 8 and negative 2. 8 and negative 2 will combine to be 6. Bring down the plus and the 5t. All right, I'm going to bring down my less than sign as well. And let's go ahead and check out this other side, right-hand side, and let's go through GEMDOS. No grouping symbols, no exponents, no multiplication I can do, no division I can do. Addition and subtraction, there is some of that, and I do have like terms. We've got 2t and positive 3t, and those will combine to be 5t. I'm going to bring down that minus 6 now. And just to kind of quickly look at that again, let's make sure both sides are simplified. Can't do anything else there. I can't do anything else there because those both are, they're not like terms. So, all right, well, let's start solving. That's part of the simplifying step. We still do need to get variables to one side, though, because I do see variables on both sides. And you may see this already. They're exactly the same, 5t and 5t, so you might already notice that these will cancel. But let's go ahead and follow through what we would normally do anyway. I'm going to be operating on both sides. So I am going to get that lollipop in here. I'm going to decide what side I want to try to get the t's on. It doesn't matter. Maybe you go like this and say you want t down on the left-hand side. Well, that means I got to get rid of these 5 t's, right? So if I subtract 5 t's, I also have to subtract 5 t's over here, right? Remember, that is the subtraction property, not of equality, but inequalities, because that's what we're working with. When we do that, we bring down our 6. Our 5t minus 5t is 0. We go less than 5t minus 5t is 0. We kind of talked about that. We'll bring down our negative 6. This is what's interesting. I didn't get my variable over to the left-hand side because it has disappeared. And that leads us to 2 options here, okay? Once your variables disappear, you're left with 2 options. You have your identity or your contradiction. Such a long word to write. All right, and that's what it is. And so one of those 2 options now, only because my variables have canceled out, I got these 2 options. It is 50-50, but we know what one's what. Let's go take a look at this. We need to ask ourselves, is 6 less than a negative 6? This is what I like to do with my students who get confused with positives and negatives. Put a money sign right there really quick. Is that true? No, $6 is not less than having negative $6. That means I owe somebody, right? So that's not what I want to do. Even looking on a number line, if we start over here at negative 6 and then went negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, all the way up to 6, is 6 to the left of negative 6? No, right? So we can see which one's less than. Really, negative 6 is smaller but this has got to be false, right? And if this is false, which one is it? Identity or contradiction?
Contradiction.
It's a contradiction.
Fake.
Not an identity, right? If it's false, it's a contradiction. And contradiction means that we have
No solution.
no solution. Wow. Looks like Tron. Yeah. So that's that problem right there. That means we have no solution. No matter what value we can choose for t, this will never be true. Never, ever will it be true. Take a look at our next one. Right. So it looks like we do have some simplifying here to do. We got negative 6 times 1 minus 1 half x, all less than 3x. Go ahead and pause the video and try giving that one a shot. All right, let's do this one then. All right, again, GEMDOS. Let's look at both sides. First, on the left-hand side, I do see grouping symbols, but everything inside, I can't do anything inside the grouping symbols here because those are not like terms. We can't multiply here. So we're going to move on to exponents. No exponents. Multiplication, division, we do have that. We could go through GEMDOS or we could go through SADMEG. I'm going to go through GEMDOS, and I'm going to do some multiplication. Remember that distribution is a form of multiplication here. So let's go ahead and do it that way. We're going to distribute, and since we're distributing, we're multiplying. Let's see here. Let's get our box ready, do our area model. It means we're distributing a negative 6 into a 1 and a negative 1 half x. Negative 6 times 1 is negative 6. And negative times a negative is a positive 3. All right, so we've got both of our terms out there. Let's go ahead and rewrite this then. We have a minus 6 plus 3x and then less than 3x. Now I want to cover this really quick. Just because I distributed doesn't mean I flip the sign, right? We don't flip the sign until we do it to both sides. So we got this left over. Negative 6 plus 3x is less than 3x. Looks like I'm done simplifying on this side. And it doesn't look like I have anything to simplify over here. So let's solve. All right, I see that I have variables on both sides. Let's get them to one side. Let's just try moving them over to the left. Let's get rid of this 3x here. Let's get rid of this 3x over here, it looks like. That looks nice. Well, 3x minus 3x is 0. Let's bring down the negative 6.
Okay.
The less than sign
is 0.
And should I write that 0?
Yeah, because there's nothing there.
So there's my 0. Well, variables canceled out, so I'm left with two options. Identity or contradiction, but only because my variables have canceled out. Negative 6 is less than 0. True or false?
True!
That is true. So what does that mean? Identity or contradiction?
Identity.
It means identity. Button. There we go. I got some.
All reals.
Means identity, which means my solutions are all the real numbers, right? All the reals. No matter what number we choose, think of any number. If you were to substitute it in for x here, this would end up being true. That's every number on the number.
So this says error analysis. And so error analysis is, I want you to pause and I want you to go through and see if you can figure out what mistake they made in solving this equation. So quickly hit pause, go through it, and then we'll talk about it. Okay, so I assume you've already done that. And so I look at this, and the best way I can think of to do this is let's go through the steps with them and see what they did. So the first thing they seem to do is they seem to be multiplying both sides of the equation by -3. Well, if I look at SADMEG for solving, I can see adding and subtraction should be first, but I notice that I can't actually add that -2n because there are grouping symbols here, right? On all fractions, the numerator and denominator have grouping symbols. So, okay, the next thing would have been multiply, and so they did. Multiplication by -3 to both sides would have been the next step. So we're going to call that the multiplication property of inequalities, the POI, right? POE is property of equalities, POI is property of inequalities. So that's correct. Then what did they do next? Well, if they dropped this down, it looks like they got rid of the parentheses, which is fine. And they went back to the beginning and said, can I add or subtract anything? Oh, they got this 1, and they said, I'm going to subtract this. And so they subtracted to one side, they had to do it to the other. So that would be the subtraction property of inequalities. Okay, and let's see what they got. -1 minus 1, I think I would have put 0 there because that's just the way I like to do things. I don't need to write it down because I have that -2n. And 21 minus 1 is 20, so they did all that right. Okay, So the next step would have been multiplication or division again. Okay, so they said times -2, so I have to divide -2. So if I take this side and divide it by -2, then I have to take that side and divide it by -2. That's definitely true, so that is the division property of inequalities, and -2 divided by -2 is 1, which I wouldn't need to write because I just have the variable, and 20 divided by -2 is 10. Well, they seem to do it all right. I don't know what's the problem. And then I go, oh yeah, it's an inequality. And so what did they mistake? What were they supposed to do with the sign here when they divided by a negative number or multiplied? They were supposed to flip the sign. So the error here is that it shouldn't have been n is greater than -10. It should have been n is less than -10. Because when you multiply or divide by a negative anywhere in an equation, you must flip the sign. I believe that is all for us today. Let's take a look. Oh, there you have it. 0 step. So when you simplify, if you multiply or divide by a negative number, you must flip the sign. That's when you simplify. Or if you get rid of that coefficient, if you multiply or divide by a negative number, you flip the sign. So remember that. Only if you multiply or divide by a negative number do you flip the sign, and only if the variables disappear do you have a contradiction or an identity. Hope that helped. Email us if you need. Go ahead and do the work underneath this slide right here, and we'll catch you on the flip side.